Any object which comes near Earth get attracted, accelerate towards Earth and ultimately crashes on Earth. We all know this happens due to gravitation force between Earth and other objects. But how this gravity actually works? Well, in this video we are going to study the same. We are going to understand the fundamental of gravitation field, its properties and how it helps us to understand our cosmos. Hello, my name is Dr. Upendra. I am on a journey to make physics simple for intermediate students like you. I hope you like the video. If you do, I recommend the other videos of this channel which is made only for you. These videos attempts to explain fundamentals of physics with simple animation. That's enough introduction. You are watching Easy Physics and let's go back to our video. The concept of gravity has been since ancient times. But it was Sir Isaac Newton who formulated the law of gravitation in the late 17th century. As per story, Newton saw a falling apple which inspired him to explore gravitation force. After nearly 22 years of study, Newton proposed that gravity must be a force, which is directly proportional to the mass of the objects and is inversely proportional to the square of the distance between these objects. From this, Newton proposed the law which states that every particle in our universe attracts every other particles with a force directly proportional to the product of their masses and is inversely proportional to the square of the distance between them. Or in simple mathematical form, it is F is equal to gmm divided by r square. This was the quick revision of the gravitation force. If you need the details, you can watch the video available on this channel titled Newton's Law of Gravitation. So now let's come back to the animation we saw at the starting of this video. The Earth and the star will have a force of attraction which can be calculated using the universal law of gravitation. But Earth and this star is separated by long distance. How can Earth interact with this star separated by thousands of kilometers? How actually gravity works? One of the most accepted theory is gravitation field. This works on the principle of action at a distance. It assumes that at first every object makes a field around its mass. This field has its own energy and momentum. Second, any object comes in proximity of this field gets attracted towards the mass. So in short, we can say gravitational field is a region in a space around a massive body where other objects experiences the gravitation force. So the gravitation field is a concept that allows us to understand how the influence of massive body extends throughout the space. Let us consider Moon and Earth. Since both objects are massive, they definitely have strong gravitation field around them. Let us drop few balls around these planets. You may see the balls get attracted towards Moon or Earth based on the strength of the respective gravitation field of the planets. Hopefully you understood the concept of gravitation field. Now let us see how actually gravitation field strength is calculated. The field strength for any massive object is calculated using a point mass. A hypothetical point mass is positioned anywhere in the field and gravitation force is calculated. Therefore, gravitation force is F is equal to gmm divided by r square. If we divide F by mass m, we get gravitation field strength E is equal to F by m, which is equal to gmm divided by m into r square. If we cancel object mass small m, then gravitation field strength E will become gm divided by r square. The quantity E is called gravitation field strength, which depends on mass of the massive body or the body which has created the field. Let us broaden our understanding of gravitation field and field strength. Earth and Moon are massive bodies which will have gravitation field of their own. Suppose I want to throw this ball to Moon. I want this ball to escape Earth gravitation field and enter in Moon's gravitation field and crash on the Moon's surface. If I throw this ball towards the Moon, it may go up but definitely returns back to Earth. This is due to stronger gravitation field of Earth compared to Moon. So if ball is thrown from Earth, it will return back till the Earth gravitation field is stronger compared to Moon's field. There will be a distance where Earth gravitation field will be weaker and Moon's gravitation field will become stronger, and the ball will not return to the Earth. If thrown with such power from Earth, its speed will gradually decrease, but once Moon's attraction becomes stronger, it will accelerate towards Moon and crashes on the Moon's surface. You might have also figured out that there may be a point where gravitation field strength E will be same for Moon and Earth, and objects will stuck between these two massive bodies. Of course, this is hypothetical since Earth and Moon are not stationary but in fact have their own motion. If I ask you what may be the range of the gravitation field, the answer may be near infinity. Obviously, its field strength will get weaker as the distance increases. For example, the water in our oceans are held due to strong gravitation of Earth. But Moon's gravity also influences it and causes low tides and high tides in our oceans. So it is logical to conclude that every particle in our universe have their own gravitation field and influences other objects. By this logic, I can say that there is an invisible gravitation field around me which not only attracts this chair but bed, the windows, curtains, everything around me, including everyone in my city and people like you who are far away and watching this video from any part of the world. But as you know, my field strength is insignificant if we compare with the field strength of this massive Earth. Therefore, all the things which I mentioned, they do not accelerate towards me and luckily does not collide with me because Earth is collectively holding all these things. Now, let us revisit the formula of gravitation field strength. E is equal to F by m. So, gravitation field strength unit should be Newton per kg, but we know Newton is equal to kg meter per second square. If I put Newton in above equation, it becomes meter per second square. If you observe this carefully, the unit of gravitation field will look familiar to you. Yes, you guessed it correctly. It is same as the acceleration due to gravity. Let me show you with the other example. The gravitation force near Earth's surface is F is equal to mg. Gravitation field strength E is equal to F divided by m, which is equal to mg divided by m, that will give you the value of g. So E is equal to g near Earth's surface. Loosely, if you consider acceleration due to gravity and gravitation field strength, they can be considered same. So now you must have understood what is gravitation field, what is gravitation field strength, and how they are actually calculated, and what is its physical significance, and why we actually need to study about this field. Now let us see the variation of gravitation field. The variation of gravitation field strength is similar to the acceleration due to gravity, which we have already seen in the previous video. You can locate the video on this channel and you can go through and you can watch it. Here in this video, I will quickly write the formula. I will show with the animation the variation of gravitation field strength with distance. For a solid sphere like our Earth, suppose a red ball moves from Earth's center to some height. We have to divide this into two parts since field strength varies differently. First from center to Earth's surface, second from surface to height h. So field strength is directly proportional to radius r and varies from 0 at the center to maximum at Earth's surface. Since field strength capital E is directly proportional to small r, therefore the variation is linear. Now let us see movement of ball from surface of Earth to height h. The field strength capital E is inversely proportional to r plus h square. Therefore, gravitation field strength will decrease parabolically from Earth's center to height h. So if we see the variation in its entirety, gravitation field strength E will be 0 at Earth's center and will increase linearly up to surface of the Earth. Beyond that, if height increases, the field strength will decrease parabolically. Suppose the Earth is hollow, or let's consider any spherical shell. If any object is placed inside a spherical shell, the force of attraction for all the direction will cancel each other and net gravitation force will be 0. So if gravitation force F inside a shell or a hollow sphere is 0, therefore gravitation field strength capital E must also be 0. So the variation from surface to height h will be same as we have discussed for spheres like our Earth. Therefore, if we see it in its entirety for shell or a hollow sphere, field strength E will be 0 till shell surface, will become maximum at surface and decreases parabolically above Earth's surface. So I hope you enjoyed the lecture. You understood the gravitation field strength, how it is calculated, what is its physical significance, and finally its variation with height and depth. In the next video, we are going to see the gravitation potential. Thank you for watching the video and see you in the next video.